Hey everyone, and welcome to The Explainer. Okay, let's just dive right into this because it's an absolutely incredible topic. Today, we're going to trace the dramatic, almost unbelievable journey of our most vital energy sources. We are talking about a story that spans literally millions of years. It starts with prehistoric organisms and leads all the way up to the very power that runs our incredibly fast-paced modern world. It is a fascinating look at exactly how the ancient past fuels our present.
So here's our roadmap for today. We'll start with number 1, nature's bountiful resources. Then 2, coal, the ancient fuel. 3, petroleum, the black gold. 4, natural gas and petrochemicals. And finally, number 5, conservation and alternative energy. All right, let's jump straight into section 1, nature's bountiful resources. Now, everything we need for our daily comfort, our survival, the whole shebang, comes directly from nature. But the fundamental stakes of our energy consumption really come down to this simple split. On one side, we have renewable, inexhaustible resources. These are essentially unlimited. Human activity isn't going to deplete them. Think sunlight, air, wind. It's always there. But on the flip side, we have non-renewable, exhaustible resources. These are present in a strictly limited quantity. Fossil fuels and minerals, they fall right here. They just can't replenish themselves fast enough to keep up with us. Which means once we use them up, they're completely gone. Keep that finite reality in mind as we explore these fuels today. Which leads us perfectly into section 2, coal, the ancient fuel. So that brings us to our first major fossil fuel, right? And it's actually one of the earliest energy sources humanity ever used. But how did this dark, hard stone actually form? Well, it happened through a process called carbonization. Millions of years ago, and I mean millions. Due to floods and earthquakes, these massive, dense wetland forests were completely buried under sand, clay, and water. You really have to think of the Earth's crust as this giant geological slow cooker. Over eons, under just immense high pressure and high temperature, and totally without air, that buried vegetation slowly cooked and converted into coal. We are currently burning through this fuel in mere decades, but the Earth took thousands upon thousands of millennia to actually make it. And coal formation isn't just a one-and-done event. It's a continuing process, which is why we get different varieties based on depth and pressure. Right near the top, you have peat, which is about, 50 to 60% carbon. As layers of sediment sandwich down and compress that peat, we get the dark brown lignite. Deeper still, with even more pressure, gives us bituminous coal. That's the soft coal you see widely used in households. And finally, at the very bottom, crushed under the absolute most extreme pressure, we get anthracite. That is the superior, hard black coal that boasts 90 to 95% carbon. It gives off the absolute most heat. But here's the wild part. Coal isn't just something we just chuck into a fire. It actually builds this invisible industrial web all around us. Through this process called destructive distillation, which is basically heating coal strongly in a closed tube without any air, that single piece of ancient rock breaks down into an astonishing variety of products. We're talking fertilizers, plastics, medicines, explosives, dyes, and even cooking gas. It's kind of mind-blowing, right? So to break it down, destructive distillation gives us 3 absolutely crucial byproducts. First up is coke. No, not the drink. This is tough, porous, black, and it is a staggering 98% pure carbon. That makes it absolutely essential for metal extraction and making steel. Next, we have coal tar. This stuff is a thick, honestly foul-smelling black liquid. It looks pretty messy, but it's actually a complex mixture of about 200 different carbon compounds. We use it as the starting material for everyday items, synthetic fibers, paints, and even naphthalene balls to repel insects. Finally, there's coal gas, which is a highly combustible mixture of hydrogen, methane, and carbon monoxide. It serves as a fantastic industrial fuel. Okay, moving right along to section 3, petroleum, the black gold. Now we're shifting the narrative. We're moving from ancient, buried forests to microscopic life in ancient seas. Millions of years ago, microscopic plants and animals died, sank to the seafloor, and eventually got buried under heavy layers of sand and clay. And because of sheer physics, these resources naturally organize themselves deep underground. Petroleum and natural gas seep through porous rocks until they literally hit a ceiling, a layer of impervious rock they can't get through. And because oil and gas are lighter than water, they naturally separate out by density. It's pretty neat. The natural gas sits at the very top, layered directly above the oil, and the much heavier water just rests down at the bottom. But Just like coal, raw petroleum straight out of the ground needs to be processed. And we do this through a fractional distillation tower. Here's how it works. Crude oil is pumped into a massive heater and vaporizes as it enters the tower. Because petroleum is this incredibly complex mixture of various hydrocarbons, its different components boil at entirely different temperatures. So the heaviest elements, the ones with the highest boiling points, like residual oil for wax and asphalt, they condense way down at the bottom. Meanwhile, the lighter fractions with lower boiling points, your diesels, your kerosenes, your petrols, they rise much higher up the tower before they cool and are collected. It's basically a beautifully organized thermal sorting machine. And the results of all that fractional distillation? Those are our petrochemicals. And honestly, we are heavily, heavily dependent on them for basic modern conveniences. I mean, we rely on LPG to cook our dinners, right? We need petrol and diesel to power our cars and our massive electric generators. Kerosene isn't just for old-school household lamps anymore. It's the aviation fuel that literally powers jet aircrafts. Paraffin wax, that's in the medicinal ointments we use and the candles we burn. And bitumen, that is exactly what we use for metaling the very roads we drive on every single day.
All right, on to Section 4, natural gas and petrochemicals.
So now that we've covered all those heavy liquids, let's take a look at the lightest, and honestly, the cleanest of our fossil fuels. Natural gas is prized right now precisely because it acts as this cleaner bridge fuel. When it's compressed under high pressure as CNG, it becomes incredibly useful. It burns super clean with a smokeless flame, and it causes very, very little pollution compared to burning coal or petrol. Plus, it has a high calorific value, which is just a fancy way of saying it packs a serious energy punch. But honestly, its greatest advantage might be the logistics. It can be piped directly from production wells straight into homes and factories. That completely eliminates the need for fleets of transport trucks. And this direct pipeline network, it already exists and is working great in places like Vadodara and parts of Delhi. Which brings us to our final stop, Section 5, Conservation and Alternative Energy. We've seen just how insanely valuable coal, petroleum, and natural gas are. But we have to circle back to our very first point today. These are non-renewable, period. Which brings us to a really heavy question. What actually happens when the Earth runs on empty? The consequences of over-extracting these exhaustible resources are severe. As these deposits dry up, we are going to face drastic increases in prices, putting basic commodities totally beyond the reach of everyday people. We're looking at massive drains on foreign exchange reserves just to import fuel. And furthermore, burning all these fossil fuels is adding immense, dangerous amounts of carbon dioxide to our air, leading directly to a greenhouse effect that drives global warming. So, what can we actually do about it right now? Well, it's not all doom and gloom. The Petroleum Conservation Research Association, or PCRA, offers some highly practical, everyday tips to conserve petrol and diesel, and they're so easy. By simply driving at a constant, moderate speed, say around 45 to 50 kilometers per hour, you maximize your fuel efficiency. Periodically checking your tire air pressure and ensuring regular vehicle maintenance at proper workshops saves a really surprising amount of fuel over the long haul. And honestly, just switching off your engine while you're sitting there waiting at a traffic light, that can make a massive dent in our overall consumption if we all do it. But going beyond just conservation, we absolutely must adopt renewable alternatives like biogas. This is so cool. In a floating dome biogas plant, a slurry of animal dung and water is fed down into an underground brick digester. Down there, in the total absence of air, anaerobic fermentation takes place. This naturally decomposes the biomass and releases a clean gas, primarily made of methane. That gas collects in the steel holder, which actually naturally floats up as it fills. When you burn it, methane produces absolutely no soot and leaves no unburnt carbon particles behind. It's incredibly clean, it's renewable energy, and it's born entirely from domestic waste. It's a total game changer. So as we wrap up, I want to leave you with this final, kind of staggering thought. The coal and petroleum that we've explored today took the Earth millions upon millions of years to create. It was a slow process of immense pressure deep inside the geological oven of the crust. And yet, at the totally staggering rate we are currently consuming these resources, our existing stock may only last for another 20 to 30 years. It's a breathtaking contrast, isn't it? Millions of years of deep geological time versus our ticking 30-year modern energy clock. Knowing this, how quickly do you think we will adapt to the sustainable alternatives that have to define our future? Something to think about. Thank you so much for joining me on this explainer, and as always, keep learning.